One of the last things we're going to look at in this unit is, as this set of notes says, parts of similar triangles. So there's different, if I have similar triangles, then there's different pieces of them that are also going to be proportional to corresponding sides. Some of those vocab terms that we looked at in our congruent triangles unit. So the first one that we're going to talk about, and it says right there, if two triangles are similar, then the following corresponding parts are also proportional to corresponding sides. The first one we're going to talk about is an altitude. Remember, an altitude goes from the vertice to the opposite side, the line containing the opposite side of the triangle, and it's perpendicular to it. So we've got that right there. And in this case, we're going to say that our altitudes themselves between our two proportional triangles. So my altitudes are here, are equal to the ratio of, we'll do AB and EM. And it works for the other sides too, so I could have said those ones. And there'll be a couple examples where you see it. So that's one of them. The next one that I've got, you'll notice that I've got the angles being cut right in half. Are the angle bisectors. If two triangles are similar, they're angle bisectors. The bisector itself, so I'm going to say QS to, what's the other one, UW. And that's that right there. Is similar to, or equal to, I should say, QP mu t. And again, I could have done these guys. I could have done these ones over here. And then the last one I'm looking at, my final part down here is my median. Remember, my median goes from a vertex to the midpoint of the opposite side. I can tell it's a median because those two are congruent to each other. So there's my medians. So much like the other ones, I'm going to say, okay, my HJ to LN, my comparison of my medians, is equal to GH to LK. So that's all those are, and those are pretty simple to set up. I just have to kind of keep track of what pieces are corresponding to which other pieces. So, for example, they told me here STU is similar, and number one I'm looking at, STU is similar to DEC. So STU is this one, DEC. So since it is similar, I want to make sure I'm maintaining order of these. So for example, if I'm looking at STU, U lines up with C. So that's how I'm kind of making that shift and making that distinction of what angles are congruent and what I can say is proportional. So what we've got here, we've got a median. That's your best bet to start by saying, okay, what do I actually have? I have a median there. And we set up there that our medians, the way I'm setting up the proportion, I'm saying my medians in one ratio are equal to the same ratio of the corresponding sides between the two triangles. I can pick either pair of sides. I'm going to go with 16 and 20 because they're better looking numbers than that 19.2 and 24. So when I'm doing that, and then it just becomes a problem like we're used to solving. I'm going to say, okay, 20x equals 16 times 15, which is 240. And x equals 12. And that's all I'm doing for all of these. I'm just following those, and they're all pretty similar. The ratio between whatever thing I've got. So right here, for example, I've got an altitude. So my ratio between my altitudes is equal to the ratio between two corresponding sides. And that's all I'm doing there. So I want you guys to try 2, 3, and 4. I think you guys can handle it. It's not, they're all set up in fairly similar ways. So pause the video and take a chance to do that. And then once we're done with that, why don't you also try number 5 on the back. And once you're done with that, we'll move on. The next thing that we've got here, we've got the triangle angle bisector theorem. An angle bisector in a triangle separates the opposite sides into two segments that are proportional to the lengths of the other two sides. What does that actually mean? What it means is, if I have got, I'm just looking at one triangle in this case, and I've got an angle bisector, in this case it's BD, and they are saying, okay, if I've got this, then the ratio of AD to DC, or the two segments that that angle bisector is breaking it into, is equal to the ratio between those two corresponding sides. The way I want you to think about this is, in the numerator of each of those ratios, first I've got AD. So I want the numerator of the other fraction to be whatever is adjacent or next to AD. So it's whatever's closest to it. These kind of stick together, and these kind of stick together, as you can see in there. So if I'm looking over here, for example, in number 6, and I'll do a couple of these with you guys. In number 6, I'm going to say, okay, my ratio, like I said up there, we're saying that this is an angle bisector. So that's my bisector. So I'm looking at the two pieces that it splits it into. I'm making that my first ratio. And I'm going to say that's equal to, my numerator is going to be whatever is close to my x, so 18, over whatever's close to my 4.8, which is 12. And when I do that math out, I get 7.2. Don't let the ugly number scare you. I know you guys think it's wrong if it's an ugly number, but it is not. So that's one of them. And now let's do number 10 together, because that one's a little bit uglier, but still manageable. Only difference here is, okay, this is my angle bisector. All the angle bisectors on these are Km. So it splits it into 27, and I don't know what this is over here, but this is kind of like some of the stuff that we did in the very beginning of the year. I know the whole thing is 45. So if that's 45, a little piece of it's 27, I know this right here is 18. And then that setup becomes exactly like what I've been doing. Exactly like what I've been doing. So I'm going to say, okay, 27, or actually I'm going to I'll put 18 first. 18 to 27 equals whatever's close to 18, my x plus 11, over whatever's close to 27, my 3x plus 9. The only thing that I would do to make this a little bit easier is I would reduce this. I would turn that into 2 over 3. Because that's not as much, not as large numbers that we're working with. Math's a little bit easier there. So then I'll do my cross multiplication, and I'll get 3 times x plus 11 equals 2 times 3x plus 9. And then again, I'm just solving. 3x plus 33 equals 6x plus 18. I'm running out of room here. And then I'll get I gotta subtract. Oops, I think I did something wrong somewhere here. Yep. This should be, that should be a minus. 3x minus 9. And then this is a 3x minus 9. So then this becomes 6x minus 18. So then when I do that, I'm going to get 51 equals 3x, and x equals 17. Okay? So again, those are not too bad to set up. We just got to kind of recognize what we got. Why don't you guys try 7, 8, and 9? And then that'll be all that we'll do for today. We'll talk a little bit about this more next class.